So, systems of non-linear equations. I just want you to jot down real quick some of the things that could happen. Okay. So if we had this case right here, a linear equation combined with a quadratic equation, how many solutions would we expect to find? This one would have 2 solutions. Does every linear equation combined with a quadratic equation have to have 2 solutions?
No.
No. What about this case right here? What about that case right there?
No.
That'd have no solution. Okay. Or just so I don't have to draw another picture. What about this case right here? So the 2 in red. Don't count that black line. But what about the 2 that are in red now? How many solutions would that have? That would have 1 solution because that's a tangent line. So, and that's just with a linear equation and a quadratic. What if there's 2 quadratics? Could 2 parabolas intersect with each other?
Yeah.
We could have something like this. That would be an instance of 2 solutions. Okay, so I mean these are just things we're going to be dealing with. Most of these we're going to solve using algebra because it's so much more accurate to solve using algebra than graphing. Because not everybody graphs very accurately, so your solutions might be a little off. But using algebra, you're going to be 100% exact. Yeah.
What would it look like if it was in memory?
It would have to be the same exact parabola on top of it. So, yeah. I think they also throw some circles at you on this assignment. So you're gonna have a circle and a line like that. So you could still have 2 solutions. A whole bunch of different things going on in this lesson. It doesn't have to be necessarily a function. You are right though. A circle's not a function. So let's look at example 1. Yeah, these are just systems of linear equations. So, solve. The first equation is x squared plus y squared equals 100. Which is what, by the way? X squared plus y squared equals 100. Parabola, line, circle, square, rectangle, unicorn.
Let's use unicorn. Circle.
It's a circle. Don't you remember anything from geometry?
I didn't know that, but I heard someone else say it, so I said it.
X squared, if it has 2 square variables, it's either a circle or an ellipse. We're going to learn about that later on. An ellipse? Anyway, this is a circle with a radius of 10. And the center, I can't believe you guys don't remember this from geometry. The center is 0, 0.
I hated geometry.
Anyway, 3x minus y is equal to 10. This is linear. That's a linear equation. So before you even start solving this, let's think about the different possibilities. Does there have to be a solution?
No.
No, the line doesn't have to go through the circle. But if it does go through the circle, there could be 2. Or the line could be tangent to the circle, and there could just be 1.
What if you have a parabola inside, like you have one that goes like a 5, and then it crosses through the top and comes down to that 4?
So a circle with a parabola?
Yes.
Like a circle and then a parabola? Yeah, there'd be 4. There could be. What if, ooh, this would be cool. What if the parabola came down and was touching the circle there and then came up like that? Then how many would there be? That would be cool. Anyway, let's talk about this one. We're going to solve this one using algebra. Solve using algebra. We have 2 choices for algebra. We have substitution or elimination, but one of them doesn't work. We only actually have one option, substitution or elimination. Which one is it?
Substitution. No, eliminate. No, substitution. Substitution. Substitution.
It has to be substitution.
Yes. No, because if you square it, then two things go away.
If you square an equation, you end up with a different equation. If you multiply an equation by one number, you end up with the same equation. It's just, in terms of it, it's just been multiplied by a factor. So you can't square something to end up with an equivalent statement.
Oh, square, like 3x is different than the square of minus y.
Yeah. So the reason that we can't do elimination method is even if we multiply this one by -2, we already actually have a plus and a minus here. But if we try to eliminate these y's, are they the same type of variable? This is quadratic, that's linear. Those don't eliminate. Same thing as quadratic, that's linear, so those don't eliminate. Elimination method does not work. Okay? It only works if you have the same type of variable, like
What if
terms.
you square root and then you have x plus y equals 10?
Square root is an operation that doesn't retain the numerical value of an expression. You can't square root or square an equation and end up with the same. You end up with a different one. So the only thing that's going to work here is substitution. We have to solve this bottom equation. Solve using substitution. We have to solve the bottom equation in terms of one of its variables. It doesn't matter which one, but probably y would be the easiest because it doesn't have a coefficient. So rewrite the bottom equation. Solve it for y in terms of x. So that's going to be y equals, come on, don't leave me hanging. 3x, what was it, 3x? Minus 10, there you go. This is y equals 3x minus 10. Now, we know the substitution method. We've used it a ton. What do we do with this 3x minus 10? Plug it into the first equation for y. Yeah. So that first equation becomes x squared plus 3x minus 10 squared equals 100.
And I assume you guys know this, but I'm just going to say it anyway, because I've seen this mistake a number of times. Once you solve an equation here in terms of another variable, you can't go back and plug it into the same equation that it came from. Understand what I mean? I've seen some students solve an equation in terms of another variable and then plug it back into the equation it came from. Well, it's not going to lead you anywhere. It's circular. You need to plug it back into a different equation.
Okay. Now this one's not too bad to solve. It's going to end up with a quadratic equation that we solve by factoring. Hopefully solve by factoring. Otherwise we're going to have to use the quadratic formula, which is a bummer. So 3x minus 10 to the second power expands to 9x squared minus 60x plus 100. So then we have 10x squared minus 60x is equal to 0. Just subtract 100 on both sides. Oh, this one does solve by factoring. How nice for us. How does it solve by factoring, though? You can factor out of 10, but there's something else you can factor out. X. Factor out of 10x. Now we're going to have x minus 6 is equal to 0. What'd you do wrong? Where is yours different? You got it? So what are the two solutions then?
6.
That's one of them. 0 is the other one. This one right here. Yeah, 3x minus 10 squared means 3x minus 10 times another 3x minus 10. So if you multiply those two together, you'd get negative 60x. Does that make sense? Okay. We okay in that x has to equal 0 as well? This one right here in particular is one that's overlooked. Most students, because this is a product, 10x times x minus 6 has to equal 0. So if x is equal to 0, that turns the whole entire product equal to 0. Now, and this is sometimes a point of confusion. Everybody put your pencil down for a second, look up at the screen. If it was just 10 times x minus 6, would x equal 0 then? No. But if you pull out a variable, even if it has a coefficient, okay, you're always going to get that answer of x equals 0. So those are the two answers for x, but are we just solving for x? No, we're solving for y.
So each of these x values is going to get a particular y value matched to that x value. Yeah.
What if instead of doing that, you add the 60x to the other side and just divide by x and then divide by 10? So we only get 6.
Yeah. And the reason that doesn't work is we don't know what x equals. And in the case that x equals 0, you'd be dividing by 0. Does that make sense?
Well, no, with the x over on the other side, then on one side 10x squared and on the other side positive 60x.
I see what you're saying. So you're saying do this, or 60x,
And divide by x.
but we can't. Because we don't know what x equals.
It's on both sides.
But we don't know what x equals.
And what if x equals 0, Kyle? Then you'd be dividing by 0. You know what I'm saying? Kind of what I mean?
You never, ever, ever want to divide by x if you don't know what it equals, because you might be dividing by 0. So the way that we did it is the only way that it could work. X equals 0, x equals 6. Now, if x equals 0, what does y equal? Y equals negative 10. How do we know? Plug it into this equation right here. But if x equals 6, what does y equal? Wait a minute. 6 times 18, yeah, 8. So the two solutions are 0, 10 and 6, 8. So we did end up with two solutions there.
It's negative 10.
Wait. Oh, you're right. Yep, 0, negative 10. 6, 8. See, compared to partial fractions, these are a breeze. Aren't they? Let's do another one. Example 2. Oh, it's only 12 o'clock. Dang it. Are you guys always looking at the clock? Am I just boring you to death? What's wrong with the math?
I really like it when you praise your development of it. That's not boring.
It's 8:37 for those of you who are freaking out about the time. At this school, it's 8:37.
It's actually 8:38 at school.
The time is shut your mouths and listen to me. It is kind of crappy that they're 2 minutes ahead.
I thought they would have fixed it over break. They fixed it and then it got unfixed.
Well, here's what happened. I went and talked to Kurt. He had a bunch of BYU students working on it, and it just exploded. So, let that be a lesson to you.
I think it was Utah students. I heard they were all wearing red.
That's not what I heard.
I don't think our trusted teacher would lie to us.
Anyway, now could we use elimination method, or do we still have to use substitution?
You can do elimination.
Why can we use elimination? Somebody said it. These are like terms now. The y are like terms, or the x's are like terms. So we could use elimination if we wanted to.
We could use substitution. Let's do elimination. Let's eliminate. Which one do we want to eliminate though? The x squared or the y? Y what?
Yeah, why? Yeah, why?
Why?
Yeah, why?
My little 2-year-old girl, she's getting into that phase where she's always asking why. Go get your pajamas on. Why? Go finish your dinner. Why? It's really annoying.
She was saying like she likes BYU. She's like, why?
I'm so upset. My 6-year-old girl came home from school about 2 months ago in love with BYU. And I asked her why, and I can't remember the boy's name, but it was some boy, because Tanner or some guy, because he likes BYU. Like, oh, no. What's negative 5 times 26? Negative 130. So we can cancel the 15x squared with a negative 15x squared, and we're going to end up with 11y is equal to negative 121. So y equals negative 11.
Away.
So now we need to go back to one of the original ones here and solve for x. First one, okay, so 3x squared plus 2 times negative 11 is equal to 26. 3x squared minus 22 equals 26. 3x squared equals 48. X squared equals 16, so x equals
Plus or minus 4.
there you go. And the reason that's important, you guys, is if you just let x equal 4, then the only answer you get is 4 comma 11, but that's not the only answer. There's one more. Negative 4 comma.
Wait, isn't it negative 11? Yeah, it's negative.
Or negative. I keep missing the negative signs. It's negative 4, or 4 comma negative 11, and negative 4 comma negative 11.
Away.
Okay. By the way, what two types of, I should have asked this at the beginning, what two types of equations are we dealing with here? Two parabolas. Okay. The picture, in case you're wondering why it has the same y value, one parabola is kind of like this. The other one's a little bit skinnier, kind of like that. So they have the same y value. They cross at the same horizontal or vertical distance, just opposite horizontal distances. Looks something like that. That's really about as tough as it's going to get for this assignment.
Thank goodness.
And now that I'm looking at it, in the book, the graphical method, you want to hear their how they do the graphical method? With graphing calculators. So, we get to skip that one.
I mean, oh shoot, dang, that sucks.
Well, that was inappropriate. That's recorded too, Maddie. I hope your mother hears this. I don't want you to repeat it. Okay, here's one for you to try on your own. Do it from start to finish. Oh my word. Example 3. Oh, Zanshin. It's a mental thing. Okay, try it. So how did most of you approach this one?
Elimination.
Multiply by negative 2?
I just multiplied by 3.
Multiply by 3?
Yeah, the top equation.
So that would eliminate the x or the y's. All right, so that becomes
Hey, this is frozen.
what's
The actual stream.
minus 3y equals 3. No, my wife took all my kids and left me at home. Because I spent the whole day before watching movies with my two brothers, like for 8 hours. So she said, "We are getting out of here."
Well, that's not how I
X equals plus or minus 2. Is that what you guys got? Okay. Well, if x equals 2, we got to find out what y equals. If x equals negative 2, we got to figure out what y equals. So, how do we figure out what y equals?
You question mark.
Which one are we going to plug it into, though? The top one?
It's easier. It's easier.
Now, the top equation is going to give you the same value of y at both times.
Regardless if x equals 2 or x equals negative 2. The reason is x is being squared. 2 squared is the same as negative 2 squared, isn't it? So both of these are going to have the same y value.
2 squared is 4. So we're going to get 4 minus y is equal to 1. So y is equal to 3. Same thing here. Y is equal to 3. So your two answers are 2, 3. Negative 2, 3.
Do we have to write it like that?
You have to write it in the form of ordered pairs because the solutions are the points where the graphs intersect with each other. Okay.